Hey guys, this is going to be an overview of significant figures, and so let's do some problems and some rules here. So remember, digits 1 through 9, those are always considered to be significant, and the issue is only going to be confusing when you have zeros, right? So zeros can be in one of 4 cases, right? You can have what we've referred to in class as leading zeros. So for example, in the measurement 0.002 grams, there is only one significant figure. And one helpful way to judge this is to take that number and to put it into scientific notation. So this would be equal to 2 times 10 to the negative third. And how many significant figures are there in that digit right there? Or that number right there? 1. Second example of zeros would be sandwiched zeros. And so that might be something like 707 meters, and in 707 meters there are 3 sig figs, and if we put that number into scientific notation, it becomes 7.07 times 10 to the positive 2, and how many significant figures are there in 7.07 times 10 to the positive 2? Correct, there are 3. Third case is where we have trailing zeros, and so we're going to say something like 526.00 grams. So in that case, you might be reading that off of a balance where the electronic balance actually displays those zeros, and that means it is going to have a total number of 5 significant figures. And if we express that number in scientific notation, it is going to end up being 5.2600, right? If those zeros are significant, we're going to include them in this digit, or in this number here. And that is going to be times 10 to the second, once again. And by the way, this is units of grams, this is units of meters, and this is units of grams. So again, in this case, there are 5 significant figures, even though the zeros at the end there, if we were to drop that zero, those zeros, and write this number as 5.26 times 10 to the second grams, numerically it might look exactly the same, or numerically we might say it is equal, but this one clearly does not have 5 significant figures. So be careful. You must always include those trailing zeros. Okay, the fourth case is the confusing case. And this is when you have a situation like something analogous to 7,350, we'll make that be liters. Now, in 7,350 liters, if we wanted that zero to be significant, then what we would do is we would express that number as 7,350 with a decimal point after the 0. So that clearly has 4 sig figs, right? If, however, we express this as simply 7,350, and we didn't want that 0 to be significant, then we would probably be better served by expressing this as 7.35 times 10 to the third. Now contrast that answer right there, that it has only 3 significant figures, with what we did over here where we dropped zeros. So here we dropped the zeros, and that was incorrect, right? We dropped the zeros incorrectly because the zeros in this number right here should have been retained. Here we have a 0 that we're asking ourselves the question, is that 0 significant? And if we want it to be considered to be insignificant, then we would drop it. But we have to, when we drop it, keep this 7 in the thousands, right? That's what that is. So we could not go ahead and express this by just dropping the 0 and writing it as 735, because in 735, is the 7 still in the thousands place? No, it is not. Okay, that's an overview of rules of significant figures, and we're going to do another one in just a moment about how to use this significant figures in calculations. Thanks, guys.